Hi, welcome to Easy BTech channel. Myself Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the how to solve a problem in 2 wattmeter method. That is, how to find out the different readings of the 2 meters, or how to find out the circuit elements by using 2 wattmeter method. We know the formula of the power factor cos phi by using 2 wattmeter method. For example, the problem is in 2 wattmeter measurement, the load connected to 30 kilowatts at 0.7 power factor lagging. Find the reading of each wattmeter. First of all, in the given problem, what are the values are given? That is given the total power is 30 kilowatts, and also power factor is given cos phi is 0.7. From that, the power factor angle phi you have to find out, that is cos inverse of 0.7. The angle is 45.57 degrees. First of all, you have to find out the power factor angle phi. Then after that, the total power P is nothing but the addition of the 2 wattmeter readings, that is consider W1 the reading of first wattmeter and W2 the reading of second wattmeter. Then total W1 plus W2 is nothing but the total power given in the problem, that is 30 kilowatts. We know the formula for total power, that is the active power, is nothing but root 3 VL IL cos phi. Okay, when this value is equating to 30 kilowatts, from that you have to find out the product VL IL, that is 30 kilo 30 into 1000 by root 3 into cos phi. We know the value of cos phi is 0.7, hence the value of VL into IL is nothing but 24,743.6 VA volt ampere. The value is V into I. That's why the units are volt ampere. Hence, find out the readings of 2 wattmeters. That is, first wattmeter is W1. We know the formula in terms of line values. VL IL into cos 30 minus phi. This is the formula for 1 wattmeter reading. We know the value of product VLIL, that is 24,743.6 into cos of 30 minus the angle phi value is 45.57. Hence, you can find out the value here. That is W1 value is 23.84 kilowatts. Cos of minus theta also cos theta. We know the formula. That's why the value is positive. Similarly, the reading of second wattmeter W2, the formula is VL into IL into cos 30 plus phi. Hence, you can find out VL IL. Sorry, we know the already we know the value of VL into IL, that is 24,743.6 into cos of 30 plus 45.57 degrees. Then you can multiply that value, you will get 6.165 kilowatts. When you can adding W1 plus W2, you also verify the values are right or wrong, hence P equal to W1 plus W2. Then you will get the given total power value is 30 kilowatts. When the sum of two readings are equal to given power, then hence the finding values are right. That is W1 and W2. So in this way, whenever in the given problem total power and power factor values are given, then by using formulas VL cos 30 minus 5, VL cos 30 plus 5, then you have to find out the readings of W1 and W2. That is by using 2 wattmeter method, we have two readings W1 and W2. Then find out the values. That is the one model. And very important model is by using 2 wattmeter method, we have to find out the circuit elements. So this model is very most important. There is three equal impedances R and L in series are connected in star, are supplied from 400 volts 50 Hz 3 phase 3 wire balanced supply system. The power input to the load is measured by the 2 wattmeter method and the readings are 3 kilowatts and 1 kilowatt respectively. Determine the values of resistance and inductance connected in each phase. That is by using 2 wattmeter method, you can also find out the circuit elements. What are the impedance value connected in the 3 phase star as well as 3 phase delta also. In this problem, the elements are connected in the form of star. First of all, we have to find out, write down what are the given values. That is the readings of wattmeters are given. That is W1 is 3 kilowatts, W2 is 1 kilowatts. Then therefore total power nothing but the readings of 2 wattmeters, the sum of two readings, hence 3 plus 1 4 kilowatts. This is the first step we can find out. And also in the problem is given line voltage. We know by default the voltage supply voltage which is given in star, it is the line voltage, that is 400 volts. The frequency value is 50 hertz. So these are the given values. Hence in this problem the power factor value is not given. In order to find out the power factor of the three phase circuit, we need the formula of the 2 wattmeter method. That is by using 2 wattmeter method, already we can know the value formula for power factor. That is therefore power factor cos phi equal to cos of tan inverse of root 3 into W1 minus W2 by W1 plus W2. So these are the formula for the power factor. Already we know the values of 2 wattmeters, that is cos of tan inverse of root 3 into W1 value is 3 kilowatts minus 1 kilowatt by 3 plus 1, that is into here. Hence by making simplifications, then we have to find out the value of power factor is here. The phase angle value becomes cos of 40 minus 40.89 degrees. Then the power factor value is 0.756. The value is positive, that's why the power factor is called lagging power factor. Okay, in this way, by using the formula, you can find out the power factor of the circuit, three-phase circuit. Then already we know the formula for total power, nothing but root 3 into VL into IL cos phi. We know the value of cos phi also. From that, here we need to find out the line current. That is, formula is P by root 3 into VL into cos phi. Already we know the value of P, that is the total power in the circuit, W1 plus W2, that is 4 kilowatts. Then replace all values here, that is 4 kilo, 4 into 1000 by root 3 into the line voltage given 400 and cos phi. Already we find out cos phi is 0.756. From that, find out the line current is 7.64 ampere. Okay, that is, the given system is star connected system. Already we know in star the line current is equal to the phase current. That's why the same value also is phase current. That is, both values are equal. IL equal to IPH. Okay, in star connection, the line current is equal to the phase current. That's why both values are equal. Then after finding IL value and we know the phase voltage also, we know the line voltage. From that we can find out the phase voltage. Therefore, phase voltage, that is VPH. We know the relation VL equal to root 3 into VPH. From that the value is VL by root 3. What is VL value? 400 by root 3 volts. Okay. Therefore, we have to find out impedance. We know the value of voltage and we know the value of current. Then we can find out the phase impedance. The formula is VPH by IPH. Remember, in three-phase circuits, the formula for impedance is VPH by IPH. Don't write VL by IL. That is, impedance always find out in the form of phases. So that's why the VPH value is 400 by root 3 by IPH value is 7.64. Then we can find out total impedance is 30.24 ohms. So this is the total phase impedance in the three-phase star connected system. Okay, in star already it is a balanced system. That's why all phase impedances are equal. All three phase impedances, the values are equal, 30.24 ohms. Then based on this impedance value, you can calculate the circuit elements. That is, already we know the value of the formula for power factor in terms of circuit elements. That is, cos phi equal to Z by R. From that, the circuit element R is Z into cos phi. By using this formula, we have to find out the resistance of the impedance value. That is, Z is 30.24 into, we know the cos phi value 0.756. Hence, the value of R is 22.856 ohm. That is resistance value. So in this way, you can find out the resistance of the three-phase impedance value. Then what is the other element we will find out here already in this problem? the given impedance is in the form of resistance and impedance, the inductance. That's why we need to calculate the value of inductance L. Therefore, by using the formula, first of all, you can find out the inductive reactance. We know total impedance value and resistance value. From that, we have to find out total reactance. Nothing but Z square minus R square square root of. Okay, this will be obtained. That is, we know the formula Z equal to, that is Z equal to R plus Jx. From that, the formula is R square plus X square square root. So from that, by using this formula, XL equal to square root of Z square minus R square. Therefore, we have to find out inductive reactance value. The value of Z is 30.24 whole square minus the value of R is 22.856 whole square. Then find out the required XL value, that is 19.796 ohms. So this is the inductive reactance. But we require circuit element inductance L. Therefore, from that, by using formula, we know what is the formula for inductive reactance XL equal to 2 pi FL. From that, inductance L equal to XL by 2 pi F. The value of XL is 19.796 by 2 into pi into 50. Then the value of inductance is 0.063 Henry, that is 63 millihenry. So that is the value of R. Therefore, what is the total impedance which is connected in the form of star R plus J X L? That means R value is 22.856 plus XL value is 19.796. So this is the impedance value. This impedance value which is connected in the form of star, that is the load is connected in the form of star. This is R phase, this is B phase, and this is Y phase. Then the impedances are equal. Why? Because the given problem, it is a balanced system. That's why all values are equal. This star connected load which is connected to the three phase supply, that is 400 volts 50 hertz supply. So that's why by using two wattmeter method, first of all you can find out the what is the power factor value cos phi. The important formula is tan inverse of root 3 into W1 minus W2 by W1 plus W2. Then after finding cos phi power factor value, then by using total power, we have to find out the what is the current passing through the circuit, three phase circuit IL. Then from that, we have to find out the impedance value. Then after that, resistance value and inductance value L. So these are very two important models. very very important in gate examinations also. Please subscribe our channel and share to your friends.